Good afternoon, everybody. I'm here on behalf of my colleagues from the floods modeling group at the JRC of the European Commission based in Ispra, Italy, to present you some updates on the development of the Global Flood Awareness System, GloFAS. The Global Flood Awareness System is a system that is presently developed and maintained by a collaboration between the JRC, the Joint Research Center of the European Commission, and the European Center for Weather Forecast. The system consists of an integration between an operational stream flow forecasting system that comes from ECMWF and a flood routing system, basically, that is run also as ECMWF based on algorithms developed in the past by the JRC and used in the least flood hydrological model. The purpose is to produce probabilistic stream flow forecasts on a daily basis and to compare them thresholds generated on the basis of climatology of floods from past simulations. It was set up in July 2011, and it's basically an integration of simulation results from the HTESSEL component of ECMWF, that's a hydrology tiled scheme for surface exchange over land, and a routing based on a simplified version of least flood that also includes groundwater storage and routing through the kinematic wave algorithm. The routing resolution is presently 0.1 degrees, so 10 kilometers, and the temporal resolution is also 1 day. Least flood capitalizes on available static maps describing the river catchments, and particularly in the most recent changes, two new pieces of information have been added, which are namely the river network map on the Global River Network database of WHO and others of 2012, and the river width map from the Global Width Map database of Yamazaki and others. The meteorological input data include ensemble forecasts from ECMWF variable resolution ensemble prediction. It's an ensemble of 51 members with 15 days forecast horizon and a resolution of 32 kilometers for the first 10 days, going down to 65 kilometers from day 11 onward. The long-term climatology used for the calculation of the thresholds of floods, flood discharges, can be either the ERA interim dataset, which is currently used in GloFAS, or basically a reforecast using the most updated version of the ECMWF models. The two versions have some difference. The main one is the different resolution, but in the reforecast forcing, there's also a reflection of the model updates, including data assimilation capabilities that have been improved. Therefore, it is of interest to compare the performance of the model based on the two different sources for the determination of the climatology of exceedance thresholds. We have taken well, basically, this is quickly the procedure how by which the thresholds are determined. You consider 30 years period of simulations with the era interim. You route them through the H-Tessel and list flood models, and you obtain a simulated discharge time series that is eventually analyzed in terms of extreme statistics. ECMWF reforecast as a reference climatology performs in a different way compared to the era interim former climatology. You can see this depicted in the map shown in the slide, where you show era interim providing higher estimates compared to the reforecast in the blue parts of the globe, and lower in the red parts of the globe that you see here. This is referred to a 5 years return period of the floods, but this can be appreciated more or less in the same way for the different thresholds considered in the system. How the model performs compared to existing data sets of flood observations. We refer here to the DFO. In this case, 102 events were selected from the period of setup of the current version of the model. If we use the reforecast of the ECMWF H-Tessel, we find that for a 2 years return period flood, we have 54% of the cases where floods were at least 50% of the ensemble members highlight a flood. Whereas 70% of the members highlight that there is any probability of a flood. Sorry, it's the other way around. In 70% of the cases where a flood is reported in DFO, there is at least one of the members highlighting a flood, whereas in 54% of the cases, there are at least 50% of the members highlighting a flood. For a 5 years return period flood, the statistics change slightly to a more, let's say, almost random distribution now. If you use reforecast instead of era interim, you have a certain change in the detection of floods. In most cases, actually, there are not appreciable changes in 55% of the cases, but there is a trend in increasing the number of situations where a flood is actually detected by the model. The era interim climatology is different from that of the reforecast in this respect. Using one or another may make a difference in the performance of the model. There was higher probability of threshold exceedance when reforecast is used instead of era interim for the majority of the flood events recorded in the DFO. The difference in probability of threshold exceedance is not significant for longer forecast lead times when the meteo forecast is more uncertain. And it was very difficult to accurately geolocate the floods from the DFO. This is also a source of errors and discrepancies between the assessments and what is recorded in the DFO. In this case, particularly, the flood events were geolocated only on the basis of the centroid of a large affected area, so this may give rise to some discrepancies in the comparison. The ongoing and foreseen work in the development of GloFAS is basically about some refinement in the routing components of the model for what concerns lake modules and improving the transmission losses estimation in the different river stretches. In the move towards a multimodal approach to the forecasts, including HTESL and KAMA, HTESL and least flood as presently done, and the full-blown global least flood forecasts. That's basically replacing the HTESL component with the hydrology algorithms of least flood. There is an effort ongoing about calibration using satellite data, for which I refer to a presentation that will be held on Friday, as you see in this reference. There is some activity going on about data assimilation using satellite observation of water elevations and other assimilation products. And there is a move towards implementing an effective web service. GloFAS SOS will provide forecasts for about 6,000 points through a web interface at the links that you see, at the websites that you see in this slide, globalfloods.eu. The portal will be online early in 2015, and that's pretty much all about this communication. I invite you to contact Peter Salomon, who is the colleague in charge of developing this system, coordinating the activities there, for any further information. Thank you very much.
For questions?
This has probably to do in part with the resolution of the catchments. So, I mean, the size of the catchments that you can reliably assess. And probably there are other reasons, but for this I really invite you to contact my colleagues, because unfortunately it's not, I'm not involved at this level of details. Thank you.